Hello, welcome to Math Myers video. We're still in Unit 4. We're studying congruent triangles. So far, we have studied 4 ways to prove triangles are congruent. Those ways are SSS, side, 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 SAS, side, angle, side, with the angle included in the middle, angle, side, angle, with the side in the middle of the two angles, and angle, angle, side. Last folks, we're going to do one that's called HL. And that stands for hypotenuse leg, abbreviated HL. Now, for those of you who don't remember, when we first talked about right triangles have a right angle is 90 degrees. So if you have a right angle, the parts of the triangles are called leg, but across from the 90, always recognize that across from the 90, this is called the hypotenuse. Everywhere you see a 90-degree angle, go ahead and draw an arrow to identify the hypotenuse. Now, a student asked a question one time, because we have a right triangle and want to call it leg, can we still call it a side? I would say that leg will be the first name and side will be the middle name, so definitely we can. I'm going to tell you that this triangle right here, 90 degrees across from it, again, this is a hypotenuse, this is a leg, and this is a leg. Now, in order for the theorem to work, we need the hypotenuse of one triangle to be congruent to the hypotenuse in another. And we need a leg of one triangle to be congruent to the leg of another. I see a 90-degree angle here, 90-degree angle here. Across from the 90, I see a tick mark. Tick mark represents a side. I have one arc here and one arc here. That states that the hypotenuse here is congruent to the hypotenuse here. But that's just the hypotenuse. I still need a leg. You see a leg here? Oh my goodness, here's the leg. Leg BD is shared between the two. So these triangles are congruent because of HL, hypotenuse leg. My congruent statement will be triangle ABD is congruent to triangle CBD. And all corresponding parts will be congruent. Next one, it says, are the triangles congruent, and if so, why? Well, the first thing I want to do is recognize that I do have a 90-degree angle, so I'm going to point across to the 90-degree angle. Over here I have a 90-degree angle, and I'm going to point across to the 90-degree angle. But guess what? I have no markings by the hypotenuse, so I cannot conclude that they are congruent. So I got to regroup. Let's see if there's anything else that I can use. We said that if it's a right angle, the sides are the legs. But guess what? They're still called sides. One tick mark, I'll call this S1. S1, S2, S2. Oh, a bell. Class changes for some people, but not for us. We're still going at it. So I got a side, a side, a side, a side, and right here, this right 90 degree, it's called an angle. This is called an angle. Folks, I can conclude that triangles are congruent. Why? Because of side, angle, side postulates. I could actually say that triangles are congruent. What triangle is congruent to what triangle? Triangle DAB is congruent to triangle CHF. Now, this part of the lesson, folks, I need to identify this because you are going to have different questions that you'll be asked, and I really need you to pay attention to the directions. This says what information is needed to show that the triangles are congruent because of side, angle, side. What do I need to show that these are congruent because of side, angle, side? Well, when I look at this, I already see a shared side, so that would be my S. I have an angle and I have an angle. So if I'm going for side angle side and I already have a side and an angle, wouldn't you agree that all I need is another side? So by process of elimination, I'm going to scratch out D and I'm going to scratch out B. So now I'm down to, do I need a C is congruent to CD, or do I need AB is congruent to CD? So in my markings, I'm going to pick this, and clearly I can see now that it's side, angle, side, and side, angle, side. So there we go. Correct answer is C. Let's take a look at one more. Let's look at number 3. What additional information do I need to prove angle? Angle, side. Well, clearly we can see an angle here, so let me mark it. So I have an angle. I definitely have a shared side. So I need another angle. Okay? And actually, I need this angle right here. Because if I get that angle there, I can go angle, side, angle, and I can do angle down here, side, angle, side, angle. Okay. I had to erase that one and start that again. I have angle, and I have a side here, and I have an angle. So I need another angle. So I need angle, angle, side, and I'm going to need angle, angle, side. So it's clear to me that I do need an angle. So I don't need a side, so I'm going to mark out B, process of elimination, no B. And I do need I, G, J, and I need H, J, G. So let's see what that is. I to G to J. Where's I, G, J? Here it is. We're going with C. If you have any questions about this one, write it down, bring it to class. I would suggest you try number 2 and number 4 on your own and give those to me in class next time to get 1 extra point on a quiz. Alright, of course we're at Denby, bells ring all day. I changed the directions a little bit. It says on some of these you might need to find some hidden congruent parts. These are the things that we call hidden. It is a shared side. You have to look for shared sides. And guess what? You must look for vertical angles. Remember, vertical angles are the bow tie or the X's, whatever you want to call them. So here we go. You must identify all the parts. Here I identified that CA is congruent to segment BD because it's given. This angle is also given. Why is it given? Because see the markings. Excuse me. AD is congruent to AD. It's a shared line. We also can call that the reflexive property. Okay? So we're going to look at number 11 together. Here's number 11. I see an angle here. Definitely an angle here. Call this one A2 because it has 2 arcs here. I'm going to call this one A1. It has 1 arc. Here, this one is called A2, 2 arcs. Here's A1. So I have an angle and an angle. Oh my goodness, I see a shared side. So folks, this is the beginning of writing proof. So we want to say that angle CAD is congruent to angle BDA. And why is that? What's the reason? You got it. It's given, and it's given because of the markings. All right, what else can I say? I could say that AD is congruent to AD, segment AD. Don't forget our bar. What's the reason? We call it shared side. I like to call it the reflexive property. Okay? One more angle. We could say angle BAD is congruent to angle CDA. Okay. Why? Because it's given. How is it given to us? Because of markings. Folks, these triangles are congruent. Why? They're congruent because of angle, side, angle. And so, what's the triangles that are congruent? We could say the triangle BAD is congruent to triangle CDA. Perfect. Actually, that's the beginning to getting you the right proofs. All right, last but not least, I got to get you to look at questions, same questions presented different ways. It says list all the congruent parts and then state whether they are congruent by the 5 postulates that we have learned. And so when I look at number 1, it is done for us. BC is congruent to EF, 1 arc, 1 arc, given. Angle C is congruent to angle F, Y, given. And then we got another side, congruent to a side. These are congruent because of side, angle, side. Awesome. Let's take a look at number 4. The directions again. List all the congruent parts. So for number 4, I will come over here and say that AB, segment AB is congruent to what? You got it, segment EF. And my reason, give me a G, because it is given. How's it given? It's given through notation and markings. Next, I would say AY is congruent to EN, Y, given. Last but not least, we would say BY, segment BY is congruent to segment FN. Wow. Y given. Folks, we got a side, side, side. These triangles are congruent because of side, side, side. Triangle LNE is congruent to triangle BYA. That concludes the review of all 5 of the triangles. When you come back, we're going to do triangle review of all types of triangles. Thank you for watching.